Alright guys, today we're going to deal with exponential growth and decay application problems. Okay guys, so let's go ahead and here's your basic function for growth and decay. Let's kind of define what each of the variables or letters represent. A is going to represent the amount after whatever time we're talking about, so it's like the ending amount. Okay, P is going to be our initial amount. Okay, so how much we start with. Okay, our R is our rate, okay, which is right there. And that's if it's positive, it's going to be a growth, and if it's negative, it's decay. So for increasing, it'd be positive, for decreasing, it'd be negative. N is going to be the number of times. Okay, so there's our N. And then our T is the time that it takes us. So there's our T right there. Okay, go ahead and jot these down. The great thing about growth and decay is it actually has a lot of real life examples. Things that we can actually model by growth with this growth or decay function is human population, how long it takes bacteria to grow, the transfer of heat, economics like bank accounts and things like that, how long it takes viruses to spread, also values of cars, just to name a few. Okay, so a town has an initial population of 90,000 and grows 1.3% each year. How many people will live in the town after 20 years? So I wrote up the equation that we'll use up top. I also like to write the A, P, R, N, and T on the side just so that we can start filling in what we know. Okay. So the first part says the initial population, which we talked about. The initial or the starting amount is our P. So we know that my P is going to be 90,000. Okay. And then if we look, it says it grows 1.3 each year. So my rate, okay, is going to be 1.3. We can't write rate though as with a percentage, so we have to move that decimal over 2 spots. So it's actually going to be 0.013 is my rate. For N, we're talking about our number of times it compounds. For this one, it just happens once a year because it's just each year. So it's just once a year. We'll deal with other ones when N's going to change, but for today, we're just going to have where N equals 1. Tomorrow, we'll do something different. T is the number of years, which is going to be 20. So now I'm going to go ahead and plug in those numbers that I got into my equation. So we have A equals, since that is the final amount that I'm trying to find. Okay, I went ahead and wrote those down. Now go ahead and copy that down. So pause it and copy. Now I'm going to go ahead and rewrite this using or breaking down what's in that parentheses. That's what I'm going to do first. So I have 90,000. And then 1 plus 0.013 is 1.013. I just did that in the calculator. Okay, and then 1 times 20 is 20. Okay, now I'm going to go ahead and put this in the calculator just as I see it. Okay, with the parentheses, and make sure that you raise that to the 20th power. So my answer is 116,528. We're talking about people, so I'm just going to round it to the whole person because I can't have a 0.3 of a person. So we're talking about people. Go ahead and label it. Okay, and there's my final answer. Now, if you look at the answer, it makes sense because we're increasing our population, and I have more people than I started with. I started with 90,000, now I have 116,000. Also, make sure that you can do this in the calculator because you want to make sure you get the same answer that I got. Okay, so we're going to go ahead and do this problem. Same thing, the value of an industrial machine depreciates at a rate of 5% each year. If it had an initial value of 13,500, how much will it be worth after 5 years? So let's kind of just start. Our A, we don't know what the amount is after. That's what we're trying to find. So I'm going to go ahead and put just a question mark there. Our initial amount, or our P, tells us right there that we started with 13,500. Okay, our R is our rate, but the key word in here is it depreciates. Depreciates means that it goes down. So this is going to be a negative point, and then move that decimal over twice, so it'd be 0.05. Okay, because we move that decimal over 2 spots, so it's 0.05. Okay, our N, it doesn't disclose what that is, so we just keep that as 1. T is our time, and it's 5 years. Okay, So let's go ahead and plug in what we know into our equation. So go ahead and write that down. And then I'm going to go ahead and clean this up with inside the parentheses. And I get A equals 13,500. And this ends up being 1 plus negative 0.05 is 0.95, okay, to the 5th power, because 5 times 1 is 5. Okay. Now I'm going to plug this in my calculator just as I see it, putting that 5 as an exponent, and I end up getting 10,446.04. Okay. And if you notice, we depreciated, so we went down in value. So I went from having 13,000 to now having 10,000, and we're talking about money, so we're going to go ahead and put the money sign there. Okay, so my answer makes sense. Let's go on to the next example. Okay, the value of a car can be found using the function v of t equals a times 0.85 to the t power, where a is the initial cost and t is in years. So a is the initial cost and t is the amount of years. Okay, maybe we'll make that one blue. Perfect. Okay, now suppose you bought a car in 2016 for $17,000. How much will it be worth in 2019? Now with this one, it gave us the equation. So I'm going to write the equation that it gave, because that's the equation that I'm going to use since it gave us an equation. Okay, so now when I have that equation, okay, if I look, well, let's think, what did it give us? It gave us how much the car cost originally, which is our A value. So I'm going to plug that in for A. Okay, that was the A value, so I'm going to plug that in for A. Okay, 0.85. And then T is time. So if I look, I had it from 2016 to 2019. So if you think about that, we subtract that. So it's actually only been 3 years. So T equals 3. So we're going to plug in 3 for my T. Now, it wants to know the final amount, which is going to be V of T. So let's go ahead and plug this into our calculator. So 17,000 times 0.85 to the 3rd power. Okay, and it ends up being $10,440. 0.125, so when we're talking about money, we'll round it to 1.3. Okay, make sure that you're doing this in the calculator so that you can see and making sure that you're getting the same answer. Okay, so that is our final answer.